everyone, welcome back to our journey of divisibility. Last time we talked about the divisibilities of 1, 2, 3, and 4. Today we're going to continue with divisibilities by 5, 6, and 7. So let's jump right in and get to the divisibility by 5. This one is a lot like 1s and 2s. It's pretty easy, it's pretty intuitive, you've been doing it for a long time. So the rule on divisibility by 5 is, does the number end in 0 or 5? And that goes back to when you were in kindergarten or maybe earlier when you learned to count by 5s. And you could almost make a rhyme out of it, you know, like a little sing-song, 5, 10, 15, 20. You may have had one of those counting games where someone, you know, is selected as it for tag or something like that. It's just along those lines. If the number would fall in that series, in that sequence, then that number is going to be divisible by 5. So if it ends in 0 or 5, it's divisible by 5. Okay, pretty easy and out of the way. Let's move on to divisibility by 6. All right, so we're going to move on to divisibility by 6. This one's pretty easy because the rule is if it is divisible by 2 and divisible by 3, then it will be divisible by 6. So we only have to remember our rules for 2 and 3. So if you remember from our last video that numbers that are divisible by 2 are the even numbers. And in order to be divisible by 3, we add up the digits, and if that sum is divisible by 3, then we know the whole number is divisible by 3. Okay? So if those two things are satisfied, then we'll know that it's divisible by 6. If you're wondering why this works, that's because 2 times 3 equals 6. Okay? So let's check out a couple of examples. Let's start with 42. Now my experience with students is that even though 42 is part of your basic 6 times table, it's also one that doesn't ever seem to quite get fully committed to memory. And if it is, people still feel kind of doubtful about themselves. And that's okay. We can use the trick to verify it. So we're going to verify that this number is divisible by 2 and that this number is divisible by 3. So first, is it an even number? Yep. So we know that it's divisible by 2. Now, is this number divisible by 3? Well, I'm going to add the digits. So 4 plus 2 equals 6. 6 is divisible by 3, so 42 is divisible by 3. All right, check, check. So since we know this number is divisible by 2 and by 3, we know that 42 is divisible by 6. Okay, let's move on to one that's a little bit bigger, not quite as intuitive. All right, so again, I'm checking for divisibility by 2 and divisibility by 3. So, is this an even number? Yep, sure is. Now, what about divisibility by 3? Well, 4 plus 2 equals 6, plus another 6 is 12. 12 is divisible by 3, so 426 is divisible by 3. Check. Again, we know this number is divisible by 2 and by 3, so we know this number is also divisible by 6. Moving on to a big number. All right, so is a number divisible by 2? It is an even number, ends in an 8, so that one works. What about 3? Well, 5 plus 1 is 6, plus 1 is 7, plus 3 is 10, plus 8 is 18. 18 is divisible by 3, so 51,138 is also divisible by 3. Since this number is divisible by 2 and by 3, we know that the whole number is divisible by 6. So that's how you do divisibility by 6. You simply check for divisibility by 2 and divisibility by 3, and if those two things are satisfied, then you know the number is divisible by 6. All right, so now we're going to move on to divisibility by 7. 7's a little bit different, and it's going to require a little practice. So we're going to do a few examples here, but then you'll probably want to try it yourself a couple of times with random numbers, like say you get off of a receipt, to verify whether something is going to be divisible by 7 or not. Okay, so we're going to do this first one. I'm going to walk through it real slow so that we get a chance to get comfortable with it. But just as a step-by-step, first we're going to take the very last digit and we're going to double it. And then we're going to subtract that number from the remaining digits. And if that difference is divisible by 7, then we'll know that the whole number was divisible by 7. If you didn't follow that audioly, because not everybody's an audio learner, don't sweat it. We're going to work it out as an example, okay? So here we have 119, okay? So first thing I'm going to do is I'm going to pull out the 9, okay? And I'm going to multiply it by 2. So 9 times 2 equals 18, okay? So I'm going to take this 18 and I'm going to subtract it from the remaining digits, so 11, okay? And when we subtract it, we get -7, okay? It's okay that the number is negative. That doesn't impact divisibility, okay? So since -7 is divisible by 7, we know that 119 is also divisible by 7, okay? So if we want to double check this and see if that actually works, okay, we can do it as a straight up division problem. So 7 goes into 11 once. 1 times 7 is 7. 11 minus 7 is 4. Bring down the 9. 7 goes into 49 7 times. 7 times 7 is 49. There's no remainder. So, in fact, 119 is divisible by 7. Okay? So, again, it's kind of a tricky process. Let's do another example so we can get a little more practice and feel a little more comfortable with this divisibility by 7 rule. All right, so we're gonna wrap up divisibility by 7s with a couple of more examples so we can get a little more comfortable with this process, because it's a little more involved than the 6s or the 2s or the 3s, right? Okay, so let's go ahead and start with this first one over here, 735. So step 1 is to take the last digit and multiply it by 2. So I'm gonna take 5 and multiply it by 2. So 5 times 2 equals 10. Okay, and I'm going to subtract 10 from the remaining digits. So I'm going to subtract 10 from 73. Okay, so 73 minus 10 is 63. Okay, so you stop and you ask yourself, is 63 divisible by 7? If you know your times tables, then you know that it is, and you would stop and say, okay, yeah, 735 divisible by 7. It's okay, though, if maybe you don't know that 63 is divisible by 7. It's one of those times tables that, in my experience, people still feel a little bit iffy about, and that's okay. We can extend this process again and just move further down. So, again, I'm going to take the last digit, which is 3, and I'm going to multiply it by 2. So, 3 times 2 equals 6. And I'm going to subtract that 6 from the remaining digit, which is 6. So I have 6 minus 6 equals 0. Okay? And 0 divided by 7 is 0. So that's still totally valid. 0 is divisible by 7. So therefore, we can say that 735 is divisible by 7. Okay? Let's move on to a little bit bigger of a number. And we'll try this one just a little bit faster because I think we're getting more comfortable with it. All right, so we're going to start with the last digit and multiply it by 2. So the last digit is 1, multiplied by 2. So 1 times 2 equals 2. And I'm going to subtract that 2 from the remaining digits. So 394 minus 2. And I get 392. Okay, I don't know about you, but I don't know if 392 is divisible by 7, and I'm almost frustrated because I feel like I didn't get very far. But let's keep at it. Let's see what happens. Okay, so again, I'm going to look at the last digit and I'm going to multiply it by 2. So I have 2 times 2 is equal to 4. And I'm going to subtract 4 from the remaining digits. So 39 minus 4 gives me 35. Is 35 divisible by 7? Yes, it is. So, since I know that 35 is divisible by 7, I know that 3,941 is also divisible by 7. So divisibility by 7, it's got a little bit more to it than any of the other rules we've learned up to this point. So you might want to practice it on some random numbers. I always like to use numbers from, like, say, receipts, because they're totally random. I can't, instinctually pick numbers that I know are going to work. So practice divisibility by 7 a little bit, and then you'll be able to use it confidently when you're trying to work on factoring and fraction reduction problems. So that's it for today. We covered divisibility by 5, 6, and 7. I hope you'll join us next time when we're going to wrap up our divisibility journey with divisibilities by 8, 9, and 10.